Stanford online class. It's AI for product managers, because I like to pretend that I'm an AI person, but I don't know anything about it yet.
Is it from Ang? Or who's doing it? Who's the professor?
So Stanford has a 5-week class in AI for product managers, and it gives like a high-level overview of all the things a PM needs to pay attention to when building an AI-focused product.
Cool. Yeah, they also have one that Andrew Yang or whatever Yang is put on for a long time. So
yeah.
Well, let's begin. We may have some stragglers coming on. I'm sure we will. But I just want to make sure that, we got recorded, so if they do come in a little later or can't make it tonight, they'll have that. And also, that I just want to make sure that you have your time that you need, Deep. So welcome. Appreciate JFrog, the associates that are here, Deep, Broch, being here. It's wonderful to have you. And in fact, instead of having me kind of introduce you, maybe if you wouldn't mind when you both present, just give a little background and then start off, Deep. Thanks again.
Okay, cool. Yeah, so I have a whole slide that says about me, so I'll talk about myself. It's I guess it's my favorite subject. No, just kidding. All right, let me make sure that I'm presenting correctly. Okay, hold on. 1 second. Okay, Google Slides, presents. Okay, can you guys see the slides?
Looking good.
Looking good?
Yep.
Great. Okay. I always need my my notes up, so as long as you can't see me reading. Okay. All right, I'm gonna jump in. So as mentioned, if you guys have questions, I don't pay attention to the chat while I'm doing the presentation, but just turn your mic on, yell at me. I'm happy to answer questions now. I'll also have time at the end for Q&A. Thank you guys so much for having me and Baruch. We're really excited to be here, and what I'm here to talk about is Helm charts. And specifically, I'm going to focus on some of the high-level concepts around Helm charts and zeroing in on security and how Helm charts can help you do reproducible security. As Ari mentioned, we are giving away a Nintendo Switch, and anyone that participates in this meetup and joins the link here is going to get a t-shirt sent to them. I've got like over a dozen JFrog t-shirts. They're like collectibles at this point. So go to this link. You'll get the presentation slides that I'm presenting now, and you'll get a t-shirt. And I'll put this slide up back at the end in case you miss it right now. Okay, so today's agenda. So what I'm going to do is I'm going to do a little brief introduction about who I am. Then I'm going to talk about Helm 3 and Helm chart files overall. We're going to do a little bit of like a scenario where we walk through creating your first Helm chart. This will help us understand where each step of the security blueprint falls into place. So in those security steps, some of the ones that are important to call out are going to be how you sign and verify a chart. We'll talk about the provenance file, which shows the chain of custody of the chart. We're also going to talk about secrets management tools. Big concept in Helm charts is where you're storing these secrets. There's going to be a few concepts that are native to Kubernetes, including role-based access controls. And then I will also show off Cert Manager, a certificate signing mechanism, and I'll actually show you how to install the Cert Manager chart. At the end, I'm going to talk about dependencies. I will show you the community product that I manage, which has vulnerability scanning built in. That'll be at the very end, and let's go from there. About me, my name's Deep Data. I am the community-focused product manager at JFrog. I actually manage multiple what are called centers, and the centers are free central repositories that we build to stay connected to the sort of day-to-day developer community. The center that is related to Helm is called ChartCenter, and it's actually our newest center. It was released just about 3.5 weeks ago, and you'll get to see it at the end. But I think the main thing to keep in mind is, given that I work on the community side, these are free products, and I'm always looking to connect with with developers and talk about cool features, talk about the direction that different technologies are going. So please contact me. You've got my email and my Twitter right here. I'll put this up again at the end as well. Okay, so the most important thing that's happened in the Helm community, perhaps, is Helm has graduated from an incubation project into a full-fledged project under the Cloud Native Computing Foundation. And with Helm 3, there's a few different new things that I want to talk over. Before we do, Helm in general, you may know, is a package manager for Kubernetes. Helm is less than 6 years old. The general history of Helm is that it was created by an organization called DEIS, and the first version of Helm was actually presented at KubeCon in 2015. A year later, in mid to late 2016, Helm 2 was released, and Helm 2 actually included some server-side components, which in the newest version of Helm have been deprecated. We'll talk specifically why that matters. Helm is there to assist your Kubernetes deployments. So just like any other package manager, Helm comes with commands like rollback, updates. There's a lot of new commands in Helm 3 that are going to help you monitor your apps and provide more metadata around the state of your application. And Helm 3 was officially released in November of 2019. Okay, so the most important thing that I want to highlight with Helm 3, and I think this is common knowledge at this point, is the removal of Tiller. Tiller was a server-side component that was basically a legacy, was built into Helm 2 before Kubernetes was using role-based access control. And Tiller actually had a vulnerability in that it ran with root access, and it opened up your applications to somebody getting control of that app and taking over, right? So the biggest thing with Helm 3 was removing Tiller, and now your user permissions, all of the access controls are managed directly in the Kubernetes API, and this has made it much safer as well as easier, essentially, for managing these permissions. A few other things to highlight, since we're talking about Helm 3, is dependencies. So dependencies used to live in a YAML file called requirements.yaml. They have now been moved into the chart.yaml file. I'll actually show you sort of each part of this as we go along. Also, we have new releases and namespaces. So release information in Helm 3 is now stored in the same namespace with a secret as the storage mechanism for the release information itself. Helm 3 also has three-way strategic merges instead of two-way strategic merges. This is just a better way to patch new updates, and it's a much safer way and smarter way to patch and upgrade Helm and Helm dependencies. Next is an experimental feature in Helm 3 is supporting OCI registries. So as Helm 3 explores using OCI registries to store and distribute charts, one of the things this would allow is for users to take advantage of some of the security that's already built into OCI, including provenance in OCI, and other features available in that registry. Next, we have chart validation. So Helm 3 has a JSON schema that is supported to do validation and linting of your Helm charts. Helm 3 also has improved custom resource definitions, which you're probably familiar with in Kubernetes. And last, Helm 3 includes a new type of chart called a library chart. So there's application charts, and now there's library charts. Library charts are basically just used to facilitate small code snippets. They're mostly, they're not really used to install anything. They're just used in your dependencies. Last, about Helm 3, I want to highlight that Helm 3 has some new commands. These are really helping you monitor your application. These help you look at all the metadata. So, metadata is pretty important if you want to monitor the life cycle of your application over time. So when you deploy, when you upgrade, when you roll back a deployment, you can actually get access to all of that history, all of that information by using these monitoring commands. So we have Helm status, Helm list, of course, and Helm history. And Helm history actually shows you the entire history of your releases. So it's really, really helpful to see, when a specific Helm version was deployed. You can also use Helm Git on any deployed release to see a full picture of it. Okay, so now I'm going to talk about Helm charts specifically. So Helm charts are a big, big part of what Helm as a package manager is about. A chart is basically a collection of YAML files that have been bundled together to help you with your configurations for your complex Kubernetes deployments. The two things to highlight around charts right now is the immutability factor, right? So because charts help control the state of your Kubernetes deployments, when you have a Helm chart, it creates a concept that I like to call like immutable configurations. This is basically configuration as code, and this means that when you have a Helm chart, you can deploy it multiple times to different teams, and you're getting a consistent experience across these different teams with each deployment for your Helm chart, as long as you don't change anything in the Helm chart configurations themselves. The other thing about Helm charts is, with access to all the metadata here, you get to see the trusted source of a chart. So I'm going to jump into the signing and the provenance file, but Helm charts also help you track the lineage of the chart, where it came from, where it was deployed, and all of that history. So what's in a Helm chart? The main four things when you create a chart for the first time is you have a chart.yaml file. And this is where sort of the metadata of your chart is declared. Then you have a values.yaml file, which is probably the most important piece. This is where all your configuration options are started. There are also two folders in a beginning Helm chart. There is a templates folder. We'll talk more about what goes in a templates folder. And then you have a charts folder where you can store subcharts. So at a high level, chart.yaml, as you're seeing here, provides a sort of metadata around the descriptive qualities of your Helm release. The other thing I had mentioned earlier is any dependencies that you want to declare in your bundled Helm chart, they are now stored here in your chart.yaml file and no longer in a separate requirements.yaml doc. Values.yaml, when you create a Helm chart, you're going to have all these configuration options around how pods interact, how your application actually works. So this is generally all stored in your in your values.yaml file. Your templates folder, Helm charts have this idea of templates, right? So you create a template, you can reuse that template. By default, there are a few files that are put in the template folder. The main ones I want to talk about are the service.yaml file. This is where your services are declared. This is port access. You can have multiple service YAML files. They don't have to be called service.yaml. If you look at lots of different organization charts, you're going to see a bunch of different services, and these files generally live in your templates folder. You'll also have a deployment.yaml file. This is where Helm generates the metadata that is included when you deploy this chart. And last is your charts folder. We'll talk more about this at the end when I go to dependencies, but this is where you would store any subcharts that are dependencies for your main application. Okay, so now the main part of this talk is what I want you to walk away with is just a blueprint for success, right? So as you use more Helm charts, whether you're creating Helm charts for the first time or you're using Helm charts that are provided publicly by different organizations, you're going to start seeing different patterns in where you need to pay attention to security and where certain charts can open and applications can open you up to vulnerabilities. So you don't have to memorize this list. I'm going to go through each one by one, but I've broken out these concepts in a way that are manageable. One other thing to call out is Helm is a package manager for Kubernetes. That means some of the security concepts I cover in this sort of overview, they are actually directly dependent and they're security tools that are being used in Kubernetes itself. So I'm sure if you're familiar with Kubernetes, some of this stuff is going to be very, very familiar to you. So the way I'm going to go through the security is we're going to kind of mimic what would happen if you're like creating a Helm chart, right, for the first time. If you create a Helm chart and you want to deploy it locally, one very common tool I'm sure you know is Minikube. So this is just calling out that you can install Minikube so you can do your Kubernetes deployments locally. I have a Mac, so I am using the HyperKit driver. I can do brew install HyperKit, get Minikube set up. And as we go through each step, at a high level, what we're going to do is we're going to create a chart. I'll show you very quickly where the services live. Then we are going to sign a chart. We're going to verify the chart and talk about provenance. Then I'm going to show you a specific tool for secrets management and why that's important. And throughout this talk, you'll see a little bit about some of these, again, commands that help you manage the state of your application, like Helm lint and Helm history, which I mentioned earlier. Before we go specifically to the Helm chart portion, since we're talking about security, one thing to call out is you should always set resource quotas. So, when you're creating a Kubernetes app, you can specify the storage and the amount of resources that each pod has, access to. So if somebody does gain access to your Kubernetes application, this is a really, really good way to make sure that they're not taking over all the resources on your local machine. This is my little circle of navigating security in Helm. We're going to go through each of these, and at the end, I'm going to present you a blueprint for how to think about security in Helm overall. Just generally, Helm charts use SHA secure hash algorithms to verify the integrity of the data in the chart. So SHA-256 and SHA-512, these hashes are used as checksums. When I show you the provenance file, you'll see how one part of how that hash is actually used. But if you're not familiar with checksums, they are kind of a digital handshake. So if I am transmitting a file to you, I will include a checksum that was created, that was generated when the file was originally created. And as I transmit this file to you, you will generate the checksum by reproducing the build of that file or doing a verification. If the checksums match, or the hashes match, this means that the file that I handed you in transmission hasn't changed at all. If any of the data changes, whether it was lost during transmission or somebody tried to maliciously change something in the file, the hashes would have changed. And that's how we verify that this is still the file that I intended to send you. So signing charts. Okay. One common tool now being used to sign your Helm charts is, digital signature is GPG. So I'm going to do a little bit of like mimicry of each step of how you would install some of these tools. I'm not doing it live because it would take much longer, but you'll see a general view of like the step-by-step. So first you want to install GPG. I would then generate a public-private key. In this example, I'm giving my key name demo key. You also will give your public-private key, you'll give it an email and a passphrase. And You'll see how that's used in a step later. When you use the command to sign the chart, it'll look for your public-private key. And one thing to call out is GPG 2.1 actually stores your secrets, stores your key ring in a different location. And Helm still uses secring.gpg as the extension. So just something to keep in mind if you get stuck. You can use the following command to transfer those keys back into a file format that Helm understands. So once I've used that command and I've signed the chart, and I built it, you get back these two files. So one is the chart itself. The other is a file called a provenance file. So you can see it has a .prov extension. So coming to the provenance file, when I do a Helm verify, I get back that fingerprint that we created earlier. And this fingerprint basically shows the checksum, it shows the key name, and it shows the email. So this is a great way to check that the author that you are intending to get the chart from is the person that they say they are. So if you do a Helm verify and these checksums don't match, it'll fail, right? So you'll know right away that something went wrong, some of the data has been messed with or lost. Next is secrets management. So secrets are basically kind of what they sound like. They are username and passwords. Sometimes they are API credentials. They're credentials that help you access other services like databases. When you look at Helm charts overall, and you look at all the different Kubernetes applications that are using Helm charts, because of the way Helm has developed, some of these secrets are in different places. You might have your database credentials in one YAML file. You might have your username and password somewhere else. There's also this concept called a config map. It's basically a YAML file where a lot of your configurations live. Both a config map and your secrets.yaml file use key value pairs to store the information. When you have something that you want to be secret, you need to encode it so that the username and password are not shown in your Helm chart as plain text. But more than encode it, you need to encrypt it. So as you see here, this is just a silly example, but basically, you can see this on some Helm charts. People will store a username and password in plain text, and sometimes they'll forget that they did this, and they'll commit it to source control. Somebody can potentially access this, later on as they're using the application. So the tool I want to point you to for today is a tool called Helm Secrets. It's kind of becoming one of the standard tools, but secrets management is it's an evolving beast, and there's more than one way to encrypt your secrets. So I'm going to show you kind of step by step how Helm Secrets does it, but I'll also point you to other resources. So the Helm Secrets plugin can help you manage everything from API tokens to database credentials, even TLS certificates. Again, we don't want any of this living in the chart as plain text. It needs to be encoded as well as encrypted. So what you would do with Helm Secrets, first you need to have your public-private key. So this is just showing, generating that key again. You get your fingerprint. You're going to copy and paste. That fingerprint in something called a sops.yaml file. So one prerequisite is you need to install sops. So for Mac, brew install sops. You'll then put that fingerprint in that file, and one way of doing Helm Secrets is storing that secrets.yaml file. I'll get to secrets.yaml file. You'll store your sops.yaml file inside a folder called helm_vars. And then you'll install your Helm Secrets plugin. You'll put your data that you want to encrypt within your secrets.yaml file, and you'll stick it in the Helm vars folder. And then what you can do with this plugin is use this command, helm secrets enc, and then point to the location of your secrets.yaml file. It'll encrypt those secrets, so they're basically unviewable. And this is an example of a result you'll get when you're trying to view that encryption. Again, these are not credentials that you can now use. HashiCorp Vault is building out they built out a whole suite of tools that can help you encrypt secrets in a lot of different ways. Again, encrypting secrets is extremely important when you're dealing with Helm charts, and the standards are kind of still being developed. Vault is a more advanced way to manage secrets. So just something I wanted to highlight. Okay, Helm lint. Anytime you're building your chart for the first time, or even you download a Helm chart and you're changing some configurations, make sure to do a Helm lint. Just check that the general layout and integrity, the safety of your chart is intact. Helm lint will quickly go through a lint of your entire chart or multiple charts, and it'll tell you if a chart passed the lint or failed. Next is pod security. So this one is something that lives within the Kubernetes community. But for pods, you want to make sure that you have a good pod security policy. Pods have all of their own permissions and configurations within each pod. Some of the ones to highlight is you want to make sure that your pods are not running in privilege mode, so that you don't, if somebody gains unrestricted access to the resources, they're not gaining access to everything all at once. So you want to make sure that that key value pair privileged set to false. Another one is making sure that your pod security policy that you've set pod access to read only, so that can't be messed with when people are using this application later. Also, most important, if you're an admin and you're setting these, make sure that your escalation is set to false. So this is going to make sure that people don't gain more access than they're supposed to for the permissions that you've given them. And make sure to prevent your containers from running as root, right? So this is another best practice when you're talking about pod security and Helm charts. And last, it's good to group all your policies together. Again, just like secrets, some of these policies and these configurations around pods can be stored in different places. Bring them all together. This is a best practice. It'll make your life much easier. And last, when we talk about pods, is just generally network policies. And this is just a policy that's gonna, it's gonna configure how traffic goes in and out of these pods, how these pods are deployed, and here you can set sort of the ports and the protocols for the different pod access. Next concept for Helm is RBAC. So as we talk about pods, we have to talk about the role-based access controls. One common tool being used with RBAC and Helm charts is audit to RBAC. Feel free to check it out. I think generally you all know that role-based access controls, you will set a role or a cluster role, and then you will bind it. You'll use service accounts to set kind of a group that has certain permissions. That group can be a single individual. It can be a group of individuals or a group of resources. So you'll use these to set who has access to what. And this is a really, really big part of keeping your Kubernetes application safe. And then service accounts, this is just showing you a snapshot of setting different service accounts. Each one can have a different name. And you can, again, service accounts can work for a normal human user or for resources. Last is certificates. So Cert Manager is a common certificate application within the Kubernetes and Helm ecosystem. It's used to basically verify the relationship between who's using your Kubernetes application getting access to the data store, etcd. So I want to actually show you a little bit about installing Cert Manager with the Helm chart itself. So I'm not going to do the live view, but you'll have access to these slides, and this is the specific steps to install Cert Manager. So first, you install the custom resource definition. So you use kube control, that command right there. Next, you're going to create a namespace for Cert Manager. Most examples, the namespace I'm going to use is Cert Manager. I will install Cert Manager with a Helm chart. And when I talked about ChartCenter, and I show you ChartCenter at the end, you can install Cert Manager from ChartCenter directly. So first you'll add ChartCenter as your repository, and then you'll use the command helm install Cert Manager. Right. Last, you can do a rollout of kube control, and you'll see the status of your Cert Manager installation. Last thing to cover today is dependencies. So Helm charts, they're YAML files. They point to other components that are in your Kubernetes applications. If you have a subchart, you can place it within your charts folder. And subcharts are basically just like your main chart. You can create a subchart using the same command. So helm create, give it a name, put it in your charts application folder. But the other dependency that I'm going to show you is your images. So here, this is a snapshot of ChartCenter, and this is showing you Cert Manager on ChartCenter. And we have a dependencies tab. This dependencies tab shows you all the images, all the container images that are dependencies inside this chart or this application. And one thing that I want to show you actually live is the securities tab that we have in ChartCenter. So what I'm going to do is I'm going to reshare my screen so I can show you that. Oops, wrong button. Okay, so let me share my entire screen. And can you see ChartCenter up here? Just shout out someone. Yep. Cool. Mm-hmm. The ChartCenter is the free ChartCenter repository I mentioned earlier. We've got a bunch of featured charts, including Cert Manager. What I want to show you is we are including free vulnerability scanning of your Helm charts here. So on every single chart that's included in ChartCenter, you can go to the security tab. And the security tab shows you vulnerabilities that exist within your chart. In fact, the dependencies tab, you can get a view of where exactly that vulnerability is within each image. And if you're not familiar with vulnerabilities, basically what we provide you here is a CVE ID. CVE stands for Common Vulnerabilities and Exposures List. It is an ID given to publicly reported vulnerabilities. We give you the general overview, so we give you the severity level of the vulnerability, what container it's living in within this chart, what component it's in, the version, and a description, right? So the reason this is important is if you're using Helm charts day to day and you see vulnerabilities pop up, with this level of detail, you can actually choose to change the configuration, the YAML files. You can include a different version of a database or a different version of a component. That'll help you make your charts more secure. So going back to the presentation mode, again, this is what CVEs are. These are all publicly available data. And the last thing to mention is, given that we released ChartCenter just a month ago, and we're exposing vulnerabilities on our UI, one thing we realized as high severity vulnerabilities, we want to make sure that chart maintainers are given the ability to engage with chart users on ChartCenter. So what we've done is we've decided to hide high severity vulnerabilities from the start. And it is up to the chart maintainer to go ahead and tell us when they want to make the high vulnerability details available. Concurrently, they can provide us something called mitigation notes. So right in the ChartCenter UI, they can create a icon. They can create a note. There'll be an icon that appears next to each CVE on their chart, and these maintainer notes show up on our UI. We don't want to penalize any chart maintainer for having vulnerabilities in these third-party components, but what we do want to do is give chart consumers enough valuable information that they know what charts might have vulnerabilities and what don't. This mitigation feature is the opportunity for that chart creator to provide some level of guidance to people using the charts. So with that, just wanted to highlight, once you've paid attention to security in your Helm charts, this security is reproducible across different teams as you deploy your Kubernetes applications. Got some notes about debugging, but what I really want to do is just wrap up and say that this is a great way to develop a blueprint for security in Helm charts. You can use Helm, so you can use ChartCenter for your trusted source of these charts. I showed you the security tab, and that is it. I will break for Q&A, and I will show this this slide like I mentioned I would. So any questions?
Just unmute for those that want to have questions. I'll have one then. Cool. So as far as the scan of the vulnerability scanning, it's not like a Claire or something like that for Docker images. It's basically looking at a database that says this version of a particular resource, such like a MariaDB or whatever like that, has a vulnerability in it, right? So there's no scanning. I mean, it's scanning the chart for those entries into that database. Is that correct? Am I assuming that?
So it's like Claire in some ways. So the vulnerability data that we provide you on ChartCenter comes from a proprietary tool that JFrog has called X-Ray. So JFrog X-Ray is a full-featured vulnerability scanning tool. It has remediation. There's some details around X-Ray on the ChartCenter security tab. Claire, of course, is open source and it's free.
Sure.
The vulnerability data that we're presenting you on the tab, like you said, it's not a tool in itself. It's giving you the information that's already been scanned from X-Ray. So I wouldn't, like you said, I wouldn't call it a tool, but it is a tab with a full view of all the publicly available vulnerabilities in that chart.
Okay, thank you.
If you happen to already be running X-Ray and using Artifactory, can you send Helm charts to Artifactory and get that same info?
It's yes. I mean, essentially, the information on ChartCenter security tab is a subset of what X-Ray already provides you. So anything that, whether it's a Helm chart or another type of artifact, X-Ray has a lot more scanning capabilities than the ChartCenter security tab does. So yeah. Okay. Any other questions?
So do you find so for instance, one of the things about Helm 2.0 was some of the vulnerabilities that were there, but one of the things that I find, like, let's say you wanted to, for example, the Prometheus operator. When you look at that chart, I mean, that thing's a beast. It really is, that values file. It's just hard to maintain those, especially when there's a large number of components like Prometheus operator has in it. Does Helm 3 help in that because things are divided up? I mean, I saw template files, the same thing, but that values up YAML, it gets really huge. Yeah.
Does Helm 3 help? Yes, because it does consolidate some of that information. I think with Helm 3, the community is still trying to understand some of the best practices of how to store these configuration options. Like I mentioned, everything from secrets to your config maps like they can have their own YAML files. I've seen Helm charts with 10 different config map files with 10 different names. I think Helm 3 is starting to move towards some better standards. So it helps, but like you said, there are still applications out there that are like Prometheus, that's like a total beast.
Yeah. Okay. Well, thank you.
Yeah.
Any more questions? Well, Deep, that was great. I appreciate it. If we could all do an applause, we would. We know that you have to leave as well here in just a bit, so thank you very much. And I assume then if there are questions in the future, your contact information was presented and they could send it out to you at that point.
Yeah, I'll put my email in my Twitter and Slack. Please, really do reach out. I like to tell everyone that I respond within 24 to 48 hours, and I'm always happy to talk to people.
Sleep also, remember, sleep is good, so you don't have to do it. That was pretty good response time. So thank you again, and best wishes to you.
Thank you.